We're going to cover the first section of conics today. The first section of conics deals with parabolas. Our goal for the lesson is to graph a parabola and determine a parabola's vertex, focus, and directrix from its graph. So a parabola. Definition: a parabola is a set of points in a plane equidistant from a fixed point F, called the focus, and a fixed line L called the directrix. This definition is illustrated by figure 1. You can see on your notes on the first page. The vertex V of the parabola lies halfway between the focus and directrix. And the axis of symmetry is the line that runs through the focus perpendicular to the directrix. So you can see all that stuff in the picture. We've got So you got your parabola, this line, the parabola line, okay, is all the points on this parabola line are the same distance from the focus as they are from the line L. So that distance that I marked and the other distance, that's the same distance. I take another, this point is equidistant from the focus and directrix, and so on, okay? The vertex is the point halfway between the focus and directrix. It's here. And then we've got this axis of symmetry. On either side of that, the parabola is the same. The graph of the equation x squared equals 4py is a parabola with the following properties. The vertex is 0, 0. The focus is 0p. And the directrix is y equals negative p. So your vertex is your 0, 0 point. And because the vertex is halfway between the focus and the directrix, that we could call the focus 0p and the directrix y equals negative p. If p is greater than 0, the parabola opens upward. If p is less than 0, the parabola opens downward. As you can see in the picture. So finding the equation of a parabola. So let's find the equation of the parabola with vertex 0, 0 and focus 0, 2. Alright, and then we sketch it. So we remember the coordinates of the focus are 0p, right? So we know what p is. P equals 2. P equals 2, and that's greater than 0. So the parabola opens upward. And then we saw from on the previous page the form that the graph of the equation of a parabola is x squared equals 4py. So we got x squared equals 4 py, and we know what p is. So x squared equals 4 times 2 times y, so x squared equals 8y. That's the equation of this parabola. X squared equals 8y. And then we've got the focus we know the coordinates of the focus are 0, 2. So I plot that point. I label it F, 0, 2. My parabola opens upward. I know the directrix is at going to be the y equals negative p, so it's going to be the line y equals negative 2. And then we have the parabola. We graph the parabola. It opens upward. The vertex is 0, 0. Looks like that. So that's the equation of the parabola and its graph. Any questions on doing that? So you need both the directrix and focus on this and the parabola opening up. I don't care how wide or narrow you make your parabola. We're not plugging in points. We could determine values and get some actual values for the sides of the parabola, where they would be, but I'm not concerned about that. I just want you to know it opens upward and where the focus and directrix are. Any questions on that? Okay, let's do another example. Finding the focus and directrix of a parabola from its equation. So we have the parabola y equals negative x squared. And we sketch the graph. So we've got, we need to put it in the form of x squared equals 4py, right? So we would solve for x squared, and we'd get x squared equals negative y. And then we know x squared equals 4py. So negative 1 is equal to 4p, right? Because we have negative y or negative 1y, right? So 4p equals negative 1. So then we would solve for p. P equals negative 1/4, which is less than 0. So we know it opens downward. So our focus is 0 over negative 1/4 down. And our directrix, what's our directrix going to be? Y equals what? Ahicha. Yeah, y equals 1/4. Good. So then we can graph it. It's with that much space, it's hard to graph exactly 1/4. So as long as it's between 0 and 1, or we can graph our directrix is that line. And our focus is 0, 1/4, and we have our parabola opening downward. So and it goes through. It's going to go through 0, 0. Right. All the parabolas we graph will go through the vertex of 0, 0. So that's what your parabola looks like. You should put arrows on the end of the parabola because it keeps going. All right. Any questions? Everybody have it? Okay, now, parabolas can open right and left as well. parabola with a horizontal axis. It's going to be y squared equals 4px. Alright, so you just have to remember, when it's x squared, it's opening up or down. When it's y squared, it's right or left. So the vertex is 0, 0. The focus is now P0, and the directrix is x equals negative P. If P is greater than 0, it opens right. If P is less than 0, it opens left. But the equation is y squared equals 4px. Let's look at an example. We have a parabola with horizontal axis. With a horizontal axis, a parabola has the equation 6x plus y squared equals 0. Find the focus and direction, sketch the graph. Alright, so we know what we've got. We've got 6x plus y squared equals 0. We've got to solve for y squared. Y squared equals negative 6x. And so then we know that the coefficient of x is 4p. So 4p is equal to negative 6. So p equals negative 3 halves, which is less than 0. So which way does it open? Shatiz?
So it opens left.
Yeah, it opens left. And then our focus is negative 3 halves. Zero, because the focus coordinate is this x coordinate is the same as P, and then the directrix will have an equation of x equals 3 halves. So if we graph this, we can draw the directrix at x equals negative 3 halves. We can put our focus at 3 halves. Focus is at negative 3 halves, 0, and then we draw our parabola. Remember, it goes through 0, 0. A common mistake is people put they put the bottom of the far right point of the parabola on the focus. It doesn't go through the focus, it goes through the vertex. It always goes through 0, 0. So it goes through 0, 0. There's your parabola. Put arrows on it because it continues in both directions. Alright, any questions there? Okay? Do I have it? Okay. We can use the coordinates of the focus to estimate the width of a parabola when sketching its graph. The segment that runs through the focus and perpendicular to the axis with the endpoints on the parabola is called the lattice rectum. Right? And its length is the focal diameter of the parabola. From figure 6, we can see that the distance from an endpoint Q of the lattice rectum to the directrix is 2p. Thus, the distance from Q to the focus must be the absolute value of 2p as well, by the definition of a parabola, because we know the point is the same distance from the focus and the directrix. So the focal diameter is the absolute value of 4p. In the next example, we will use the focal diameter to determine the width of the parabola when graphing it. So we have the focus, directrix, and focal diameter of the parabola. Find those things. Y equals 1/2 x squared, and sketch its graph. Okay, so we start out. We have y equals 1/2 x squared. What's the first thing I have to do? What's the first thing I should do? Yes.
Solve for x squared.
Yeah, we solve for x squared. So it's x squared equals 2y. So is this parabola going to open right or left or up or down? If it's an x squared.
Right?
No. X squared. X squared opens
Up or down?
up. Yeah, because the 2 is positive. It's going to open up. So now we know 4p is a coefficient of y, so 4p equals 2. And that's, we said that 4p was the length of the focal diameter in the previous page. So that, we know the length of the focal diameter. It's 2. We solve for p. P equals 1/2. Right, so if p equals 1/2, then we know the focus is going to be the point 0, 1/2. And the directrix is y equals -1/2. And we can graph it. So we have the directrix -1/2, the focus 1/2, and then we have the parabola focus equals 0, 1/2. Alright, so there's our parabola. So we found everything we needed to. So really the only thing different on this one is we found the focal diameter. You just have to remember it's 4p. You've got to find 4p anyways. To find p, you separate 4p anyway. So it's just an extra step, length of the focal diameter. Any questions? Okay, one more. I think there's one more example here. One more example. An application. Finding the focal point of a searchlight reflector. A searchlight has a parabolic reflector that forms a bowl, which is 12 inches wide from rim to rim and 8 inches deep. If the filament of the light bulb is located at the focus, okay, so it's above the vertex, it's at the focus, how far from the vertex of the reflector is it? Alright, so we have to find how far this point, this filament, how far the filament, which would be your focus, is from the vertex, which would be down here. We have to find that distance. Okay? So here's how we would solve it. So we draw the parabola, okay, and put the vertex at the origin, and we know that this parabola is opening up. Its axis is vertical. Axis of symmetry is vertical. The equation of the parabola that is vertical is x squared equals 4py. So we can we know some values that we don't know where the focus is, but we know some values for x and y, right? X is 6, y is 8, so I can plug those in to find p. 6 squared is your x value. 6 squared equals 4p, and y is 8. 8. So I write that equation, solve it out, and I get p equals 9/8. 1 and 1/8. So your focus is at 9/8. The distance between the vertex and the focus is 1 and 1/8. Because the filament is positioned at the focus, it is located 1 and 1/8 inch from the vertex of the reflector. Everybody understand? Any questions on that section? Okay, very good. Now we'll have to shift gears and go back to Euclidean